So you're very welcome to this morning's CPD. Thank you so much for taking the time to be here. We're joined this morning by Jason Stewart, who's going to cover urban geoarchaeology for us. So Jason has worked in commercial archaeology for almost 20 years since 2007, and 10 of those has been spent with Museum of London Archaeology. He also has commercial experience working with Headland, Oxford Archaeology, ORSK-ADAS on large-scale urban infrastructure projects, and has an MSc in geoarchaeology from University of Reading. All of which to say is he is extremely well placed and qualified to lead this morning's CPD, and we're very grateful for him for giving over the time. Jason's going to talk for the next hour or so, and then we're going to have time for questions at the end. I'd ask you just to keep yourself muted for the duration of Jason's presentation, and then there'll be loads of time for questions towards the end. So Jason, I'm going to hand over to you and let you work away. Thank you.
Lovely, thank you. Can everybody hear me all right and everything? Is the slideshow showing?
Yes, we can hear you.
Grand, lovely.
See it too.
Sweet. So as mentioned, I'm Jason Stewart. I've worked in various field consultancy and paleoenvironmental roles over the last sort of 20 years. I've mostly been working in London, but I've also worked in other urban environments like Oxford, places like that. I've done a mix of sort of field work, a mix of consultancy. I've done paleoenvironmental sort of assessments, things like that. So I've done a little bit of everything over the last few years. So yeah, basically, I'm going to give a quick overview of what geoarchaeology is, just in case anyone's not 100% familiar with it. But basically, the quick answer is answering archaeological questions using techniques from the earth sciences. So there's a lot of stuff about problem solving, landscape formation, site formation, deposit formation, that kind of thing, security of context, how it ties into dating and finds, things like that. There used to be a saying by Renfrew, I think, of all archaeological problems are sooner or later geoarchaeological problems, but I think that might be overstating it slightly, I think. So sort of there's three main elements to geoarch, where there's the on-site stuff. So I could spend a lot of time watching borehole rigs and things like that and going out to excavations. Spend a lot of time in the lab, cleaning soil, recording soil, doing very detailed descriptions of soil, and then putting all that data into databases and spreadsheets to map deposits, both sort of landscape scale, site scale, and sort of small and even microscopic scale, things like that. So geoarch tends to tie in with other aspects of environmental archaeology, so archaeobotany, archaeoetymology, paleoenvironmental things, pollen, diatoms, ostracods, things like that. Sort of try and make a sort of a wider ranging sort of environmental story about landscape change in the areas of sites and developments. It ties into sort of other aspects of archaeological science, geochemistry, said DNA, things like that, and sort of general fieldwork, shenanigans, lots of slopping around muddy puddles and going out and taking samples, recovering cores, things of that nature. A lot of my time spent doing geotechnical watching briefs on site developments and things like that. It's important to have a geoarch out on site because I tend to do high quality recording in very great detail in a way that on-site geotechnical engineers don't tend to. Their conception of made ground as a rule tends to be very broad and very non-granular in that they will treat any made ground, be it Roman, medieval or 19th century, as made ground, and it will tend to be in a log as made ground with bits of concrete and pot, whereas I will tend to do a granular sort of from 0.3 meters to 0.6 meters, there's Roman pottery in, and it's potentially a Roman makeup there, things like that. So it's different things to different people. Also, if I'm on site, I can do things like opportunistic sampling. If we come across a high value peat deposit we want to radiocarbon date later, I can take a sample of that and piggyback off the program and get a pathfinder sample of that and work out a date for the formation and the finishing of the formation of the peat. So I don't have to go out and take purposive samples later on with my own rig. Also, if I am out, I can put extra boreholes into the ground investigation program to allow me to take samples on my own without having to spend extra money for a second phase of work, remobilization, things of that nature. So in a way, it is value added. In terms of desk-based approaches, tend to start this off ideally before anything's gone out and as part of sort of a desk-based DBA approach, things like that tied into sort of that level of pre-works assessment. So I'd look at, you know, geological mapping from like the GSI or BGS in the case of the UK, see what superficial deposits there are, what potential those deposits are, if it's alluvium or wetland environment, or if there's fluvial glacial deposits or river terraces with paleolithic potential, you know, fluvial sands and mesolithic potential, things like that. I'd look into old maps, see if there's any paleo channels or things like that that may have existed prior to their infilling, that kind of thing. River straightening, mills, that kind of stuff all has an effect on what deposits you might find, whether there's an interest. Also, I tend to look at historical borehole data, either from nearby sites that are on the planning portals and things like that, or things that are held in archives, look at the GSI or BGS and things like that, so I can look and see what previous sediments have been found, how that correlates with what we're expecting. The only problem that is some of the logs are quite old. It's like some of the logs are from the 1860s in some places and are a little bit lacking in their descriptions. I've sometimes had descriptions with single word things like mud, which is not especially helpful in forming an archaeological interpretation. But obviously, the newer the log, the better generally as a rule. Obviously, tie it into grey literature of previous archaeological works, nearby sites, what deposits they were found, is their makeup, is their settlement, you know, what kind of depths they're getting, how much truncation has there been, that can all be looked at and modelled. And also, nowadays, we sort of tie things into either LiDAR data or satellite imaging, Landsat, things like that, where even though we're in a developed urban environment a lot of the time, we can still get information from the surface deposits showing, you know, areas with lower, like infill channels, things like that, sloping. The landforms still exist, even if it's paved. So you can still sort of get a feel for the mapping the territory, even though, you know, it's totally covered with 1960s flats and car parks. You can still sometimes get a feel for that. So this all tends to feed into deposit modelling. It's basically a way of synthesizing all the data I've mentioned previously, the GI data, the archaeological data, any information on sort of basement depth, truncation, and you can sort of use that to type together and highlight areas, say, of which were previously channels in the past, which areas are high and dry, and thus, you know, more likely to be settled in the Mesolithic or whatever, and target your work accordingly. You can use it to model the hydrology of the site, what the water table is doing, if there's any buried wet waterlogged remains you want to preserve. You can model where the water table level is and how it sits in that, and how the development and the basementing or whatever might change that. So you can get a feel for sort of preserving waterlogged remains, not only on a site you're working on, but in the wider area where you are. Sort of two main tools in sort of deposit modeling are transects, which provide a sort of a 2D slice between all the deposits and correlates deposits with similar deposition environments like sands or fluvial gravels or peat deposits, things like that. But what I think it doesn't do very well is it doesn't do very well with archaeological deposits, because the way they're modelled doesn't work with the way that sort of archaeological features are very straight cut, or ditches and things like that. The model and the way the maths works struggles to deal with sort of the slightly ephemeral, non-linear nature of archaeological deposits. I know things like this have been done in the past for sort of lakes and mires and various river deposits as well, but they are very useful for urban environments because you get to model them out of makeup and basement levels and things like that, and get sort of an idea of deposit thickness for when you come and do trenching evaluations, what your impact depths are for basements, things of that nature. So as you can see in this diagram here, I've color coded the different sediments. Each sediment's got a different color. So sand and gravels there, the sort of sands there, and then you've got alluvial clays in that nice blue. So it gives you sort of an instant recognition of what's happening on the site, basically, in terms of what the depositional story might be. Then if your data is good enough, you can put it into a 3D, not 3D, this one's 2D, but a 2D plot of what the underlying topography was. In this case, this is what the topography was like at the end of the last ice age. You've got sort of an area of higher ground there, an EOT, and then two sides of a river channel on either side, showing that that area is high and dry and thus has a potential for settlement in sort of the Mesolithic and early Bronze Age period, where it had been a nice ecoturnal area on the edge of a river channel where you can fish and fowl and, you know, do various things like that on it. So we could target, and indeed did target, that for trenching and further work later on. You can also use it to show, say, thickness of peat deposits or occupation deposits, makeup deposits, things like that. Anything you want, really. You can do it for surfaces for different things. So you could do top of truncation, stuff like that. So you could show differing depths of piling and stuff and things of that nature. The only problem with this is if you're in an area of low quality data, or your data isn't particularly well spread out and it's clustered, you will struggle to get a good surface. Because if you've got big gaps, then it struggles to make up the data and it ends up looking a bit weird, and you end up with some quite psychedelic sharp shapes that struggle to explain. So yeah, this is a case study for a big job that was done by Historic England in the early 2010s to late 2010s. It involves a redevelopment of a large area of southwest London in Battersea and Nine Elms, which was historically an area of car breakers yards, industrial things, meat storage, that kind of stuff. And then it's been rejuvenated to become luxury flats, American Embassy, things of that nature. So during the planning process, a decision was made by Historic England to have a project on the Battersea Channel, which is a infilled tributary of the Thames, to model and pull all the different geoarchaeological contractors, of which there are about 7 or 8, data into an overarching deposit model and publication. So going for sort of an aim of collaboration rather than competition, try to remove that sort of thing of people jealously hoarding their GI data and their site data. As you can see in the sort of bottom right diagram, you've got the current course of the River Thames and various gravel islands, and then channel way to the south. So you can see on the sort of bottom left photo, there's a little buried soil at the top of that thing, which was under a petrol station at one point. So thus basically making any kind of radiocarbon dating of that peat very, very hard, because you'd get an old date from the fact it's filled with petrol. So that was great fun. You can also see sort of channel deposits and sand deposits in the top 2 photos, which are basically where the new Nine Elms tube station is going to be and the new Battersea tube station is now. So that shows sort of the variety of alluvial and fluvial channel remains we get in there. Basically, we managed to go from a very patchy deposit model to a quite detailed one, which we've then been able to use for future sites and be able to use that as a predictive model in terms of what depths and thickness of alluvium we'll be getting, what the potential for prehistoric occupation, because there is prehistoric occupation on there. We've had sort of works bare bone, bits of struck flint, things like that, some evidence of early Bronze Age settlement on some of the gravel highs, things like that. So it's been quite useful as a predictive tool when we've gone into the next phase of development for sort of other areas around it and the regeneration of some of the flats. And the Thames Tideway project, which had a pumping station through there, we've managed to use that data quite successfully to sort of design the mitigation strategy. So that's been useful. Sort of the general field evaluation techniques we tend to do in geoarchaeology, we tend to use geophysics like GPR and electromagnetic tomography because we can use that to get a deep slice through the soil in a way that you can't with sort of the shallower stuff like resistivity and magnetometry. Obviously, we use borehole surveys with usually commercial rigs, or auger surveys with either hand augers or petrol percussion augers or electric percussion augers, and sort of your standard trial tension, trial pitting, in a similar way to how you would do it for sort of evaluating archaeological sites. So yeah, sort of the EMS surveys will give you a nice little sleep through here, but I mean, one of their boons is they measure the amount of moisture in the soil. So if you're looking for previous landforms, old river channels, things like that. In an urban area, you will get higher signal from the wetter deposits. And thus, if your site is sitting on a buried paleo channel or something like that, and there's only been infilled and built upon, you've got a better idea of seeing that than you would if you were doing something that only reached, you know, a meter, something like that. And same with GPRs, you get a nice sort of slice through sediments rather than sort of a linear planning thing, and you can obviously go through, there's a potential to go through concrete slabs and things like that, which, you know, can impact other forms of sort of ground truthing. If you're having to break out a slab or do diamond cutting for, you know, getting a borehole in, it may slow down your rate of drilling and mean you have to be a bit more selective in where you put your boreholes in your trial pits. But if you've got a good geophysics data, you can definitely build on that and be a bit more specific about what you want to do. Yeah, borehole and auger surveys are one of the primary tools we do in sort of GeoArc in urban areas. They're good for getting a small window into deep deposits. I mean, some of the deposits I've done out in sort of the Thames estuary can go down 25, 30 meters of, you know, different phases of peat and wetland deposits and fluvial river deposits, things like that. So you'd struggle to dig a deep trench. I mean, some of the sites out in Bangladesh and things like that, the Ganges are sort of up to 100-meter deep in sort of the thickness of Holocene alluvium there. So, you know, it can be quite major sort of depths. Not good for finding archaeological finds particularly, because obviously the windows are sort of quite small. I mean, I have done sites where we've had Roman rings out of it and flint work and things of that nature, but it's very much needle in a haystack kind of thing, and it's more for characterizing the deposits than finding things. I did a site in Bath many years ago where we had about 80 boreholes because the consultant was very desperate to find some Roman finds in flint, but it didn't really work, surprisingly. Yeah, so different techniques have different sort of costs, recovery potentials, and working depth. So it's very much a trade-off with budget, speed, logistics as well. If you're working in sort of tight basements and things like that, some of the bigger rigs will not get in there. So you have to either do sort of hand augering or use a window sampler or an archery rig or some of the smaller rigs to get in there, which obviously has a trade-off with cost as well, and timing. First off, you've got sort of hand augers and percussion petrol augers and things like that, which are quick, they're relatively cheap, there's less logistics and health and safety shenanigans and rams. You're not having to back a large rig into a construction site, things of that nature. But they are best for sort of shallow remains, sort of 3 meters, 5 meters. I mean, I have gone down sort of 6, 7, 8 meters with percussion rigs before, but it becomes a sort of a manual handling issue then, because you're lifting up quite large weights of metal and things like that. Another issue is most of the time the samples are open to the elements in the sides of the hole, so you're not always totally certain that the sample you're taking has got stratigraphic security and hasn't been intermixed. So if you're taking things for pollen or DNA or radiocarbon, you know, there's a slight worry as to whether you're testing the right thing. But nowadays you can get little sock liners for the open window samples for the cores and things like that. So there are ways around it, I think. Obviously there's a manual handling risk with what is quite heavy kit, and you're sort of pulling things out and you can damage your back quite easily. So obviously people have to be sort of trained in how to do that and things. You can't just shove people out on site with the gear and hope they sort of turn out all right, and they will sometimes get it stuck if they don't know. But, you know, for things like ditches and basements and shallow stuff like that, it's quite a good system. Whereas for sort of commercially available borehole kit, there's sort of 3 main types of rig. There's a window sample, which comes out in a lovely little metal tube, and that goes down sort of about 10 meters, give or take. They can get into quite small areas. You can get ones that disassemble and can go downstairs. Sediment comes out in a big meter-long tube, so you've got that element of security, and you know what the top depth is, you know what the bottom depth is most of the time. So you've got that, it makes recording it a lot easier. Then slightly bigger than that, you've got a cable percussion rig, which is basically a big metal tube on a big rope, and it's dropped into the ground, and it comes out in a big bag or in a little 40 centimeter long tube. So that's sort of good for sort of sampling gravels and things like that, where the window sampler doesn't have enough oomph to get through the gravels because it's only got a small weight on the top of it. But in terms of sort of seeing contextual boundaries and doing that really detailed recording, you want to do sort of, if you're looking at the changes in estuarine, sand content or something like that, you sometimes struggle with cable percussion. Whereas the biggest sort of rig we got is the kind of thing on the bottom right-hand side, which is a rotary rig. It can go 60 meters deep if it needs to. It can core out rock, but what we tend to do is get it to take out 1 meter long or 1.5 meter long sediment cores, which you can do quite comfortably, but they are quite expensive and they're quite big. And usually you've got to get them brought in on a low load or something like that. So logistically, it's a little bit more complicated, but you do get a better quality of sample as a rule. Other things that we have to do is trial trenching and test pits. So you get a wider window into the sediments, which is good. So then you can see sort of depositional boundaries, whether there's any rippling, things like that. You get a proper, you've got a better chance of seeing fines in there, if there's any fines. The working depth can be problematic. A lot of construction sites now are very, back in the old days, you just dig a 5-meter hole, stand next to it, and everybody was happy, sort of. Whereas now it's very much maximum depth of 3 meters. You've got to have fencing around it and a walkway, which is all good because it's quite dangerous if you don't do it properly. And there's been lots of instances of things collapsing. So you've got to so you basically got sort of the temporary works of it, the health and safety aspect of it. Water management is important because if you're in a floodplain or something like that, then as soon as you hit groundwater, you're going to have problems with your trench caving in. And then in sort of terms of sort of trial trenching, we tend to do either box trenches or sort of inverted ziggurats, step trenching. I've worked with a lot of engineers and people who are very insistent we batter the sides, which doesn't really work for geoarchaeology. You want to be able to do a proper recording of the face and sample it if needs be. But if you do it at a 45-degree angle with a nice machine smooth, bucket smoothed edge, it does not work at all. So that's a sort of a constant argument in terms of getting what we need. Obviously, you get a better view of any depositional changes, any fascies, any grading, any banding, any things like that. Sort of the nature of the changes in the sediments, the boundaries, because you can see meters of it and you can see how it changes, and you can do a very, very detailed description in a way you can't do with a single point of the auger, basically. So, yeah. Then a lot of what in urban areas, what I used to do was go out onto site work on already existing archaeological sites and go out and do detailed recording of the sediments, record sample sections, do very detailed recording of that, the boundaries, how I've taken the samples, what I think the provisional deposition on site environment on site is, so I can talk to the supervisors, the project managers about what I think needs to happen. I've also gone out with sort of an environmental archaeology hat on and taken samples. So both monoliths, bulk earth samples, OSL samples even on occasion, things like that. I can feed it sort of into sort of intra-site stuff, so I can talk to the people on site about what's going on in the wider landscape, give them an idea of what they're seeing and how it might feed into what they're digging, so how I think pits have silted up, various taphonomic things, flood deposits in sort of urban buildings and streetways and things like that I've talked about, and sort of floor surfaces and alleyways and how they're maintained and sweeping and things of that nature. You can sort of have a chat about that, so you can sort of get a better quality description from some of your diggers thinking of that, things like that, and generally give advice. So there's also a lot of sort of dealing with sort of structural flaws and gridding them up and sampling them, but dealing with buildings, outdoor surfaces, things like that, and sort of trying to work out use case, activity area stuff. I've gone out to sort of evals where we've had sites that are entirely covered with colluvium to a depth of sort of like 60 centimeters, and it's just covered in a thin layer of hill wash deposit, and basically told them they need to remachine the entire site because all the prehistoric stuff was sitting under that. It was not a particularly happy conversation, but needed to be done. A lot of the stuff I've done in urban areas have been working on linear projects. So a lot of sort of linear projects in the UK have quite heavy geoarchaeological components. They tend to be crossing a variety of geologies. They tend to have areas where there's concentrated areas of either archaeology or occupation. Tends to be sort of railway schemes like Crossrail, Northern Line Extension, or railways, road schemes like A66 I've done GI work on, and various cable routes and water routes. They will have sort of challenges that differ from your normal excavation site or development site if you're doing something like housing or a luxury block of flats, in that you've usually got quite a long site with different areas of things going on at different times. They're also quite complicated to model because obviously if they're linear, you get a great set of data for doing a transect. But if in terms of doing anything 3D or sort of landscape based on the wider area, you might struggle because you've got a very concentrated area of quite a lot of points, and then you've got very little around the outside of it. So sort of teasing that together in sort of a larger way can be quite difficult sometimes. It is a bit of a trade-off, I think. So some of the sort of geoarchaeological approaches to settlement in urban areas include sort of taking of bulk samples for geochemical analysis. So you've got phosphate analysis, ICP-MS, XRF, sorry, X-ray fluorescence, and X-ray diffraction, like that little gun there. There's a little portable XRF meter. You ping it on there and it tells you what elements are in there, which is quite good for sort of industrial areas and trying to work out what's gone in certain areas of, if certain areas being used for tanning or, metal production, that kind of stuff. A lot of that sort of stuff for buildings is floor surfaces taken in a gridded system, so sort of half a meter grid sometimes, things like that, and you label them all up, and then you can map it as a spartly system of certain areas of high activity, low activity. You can couple it into micro artifacts stuff. So if you sieve things to say 25 microns, sorry, 250 microns, you can get a look at micro debitage in flint, bits of daub, bone working waste, that kind of stuff, and get a feel for sort of what areas were used for in a different way than you get from sort of macro artifacts, because they tend to move around and are portable, whereas micro artifacts move around a lot less unless they're being swept up. You can obviously do things like magnetic susceptibility and phosphate for sort of finding out what areas are for buyers and animal stabling, and which areas of sort of have occupation. You can go out and grid an area up and use it as a sort of prospective technique for sort of which areas have high phosphate and have likely had animals or humans there. Can use magnetic susceptibility I've been used a lot on some ditches by some companies and sort of things that slowly infill to work out if there's a hiatus, the sort of sub-area weathering causes a increase in magnetic charge, and that can be measured with the MagClass machine. So you can sort of measure down a ditch and see where there are potentials for hiatuses in the deposition environment. So you can sort of get a feel for your sort of taphonomy of your ditch and how it's formed, stuff like that. You can couple it with sort of micromorphological sampling across convex boundaries and things like that. So you get sort of a vertical feeling on how the floor's formed. Is there plaster across there? Has it been swept? Has there been a gradual build up on top of it? You can sort of things like that. Definitely sort of a more microstratigraphical approach. Some of this stuff is quite small, like 3 or 4 millimeters across some of the bits. You do get a sort of a more feel for sort of use life of buildings and how people are using it. If things like Roman wall plaster, you can sort of get a feel from how the floor is, if it was replastered regularly or semi-annually or seasonally. You can answer sort of some of those questions, but those samples tend to be taken more of on a judgment base and target vertical change in contract boundaries than the sort of geochemical stuff, which tends to be on a plan basis and on a gridded systematic thing. So there's an element of sort of trust and judgment there that is different. So a lot of the stuff I've done in urban areas, I did a job in Northampton recently that has had a buried course of the River Nene on top with a scheduled monument of a Saxon palace on top of it. And we were talking about pile depths and sort of how that's going to affect the hydrology and the preservation of waterlogged urban remains. So we tend to sort of correlate the GI data we've got from existing GI works and any GI works we've done, find out the data that liaise with hydrologists and people like that to work out what the existing hydrology is doing, what the possible impacts of the piling or the basement works we're doing is, and work out what the effect it's going to have on both on site and on the surrounding deposits. Because obviously it's all well and good saying we're going to preserve something in situ, but if it isn't actually changing the waterlogged environment and all our organic remains are decaying, is that really preservation in situ? So we can feed all this stuff into sort of management plans, local authority, engagement meetings with the county archaeologists and things like that, and the Ancient Monument Service, and get together a management plan that sort of works for the sediments and ensures that we're doing what we say we're going to do. One of the sort of big urban case studies of recent years was the Lee Valley Mapping Project and the work on the 2012 Olympics in sort of East London. This is a sort of a former highly industrialised area of East London, which had lots of car breakers yards, fridge storage, various dumps and waste tips. And then they decided they were going to regenerate the area by putting the 2012 Olympics on top. But prior to that, there'd been a Aggregates Levy Sustainability Fund grant for the British Geological Survey to redo all the mapping for the Quaternary sediments there relating to the River Lee, which is one of the big tributaries of the Thames. It runs from sort of Hertfordshire, Luton down into the Thames at Leamouth. There's a lot of sort of prehistoric settlement around there, and a Roman settlement at Old Ford. There's lots of sort of braided river systems and things like that from left over from the last ice age, and the area sort of been modified quite a lot in the medieval period because of lots of different mills and relief channels and various attempts at controlling the river and using it for power. So these deposits were remapped. They reviewed all the historical borehole data from the 19th century. They redid some of the drilling with different methods and different recording systems. And then obviously when the Olympics came along, they tied in that deposit model they made and then refined it by digging doing more borehole work and more trial trenching work. So it showed the importance of firstly making a model, which is good, and then doing ground truthing of your model and then going back and revising your model based on what you found from digging all the holes. It's all very good having a model, but the model is not sacrosanct and needs to be updated with new information when you get it. So you can see in these pictures I've got, there's a lot of stepped trenches here, and that is on one of the riverbeds of the River Lee, of a former paleo channel. You can see sort of the gravel down the base, and then various kinds of medieval ground raising and sort of the top 3 steps of that. I think we got a nice hand axe out of that one at some point. And then the sort of on the bottom left, there is remains of there was a Victorian and Georgian streetway. It was sort of entirely buried by 20th century makeup. It was about 10 meters down, and that area of shoring there is 10 meters wide by 10 meters long. It was a very, very big dig. Obviously, it was a great opportunity to sort of ground truth our models on a sort of quite a larger area and tie it into the archaeology of, how was that used in the post-medieval period and the medieval period. And then, of course, GeoArch also feeds into post-X. So you can assist, coming off site and deciding what samples are useful to be used, what samples are less viable. We can assist with constructing the site narrative. We can obviously do the sort of first paragraph landscape and environment bit, saying what the environment was like in the past, but also we can sort of feed that into what was the environment like during, the occupation of the site, during periods of rapid urbanization, things like that. We can sort of use Osterkod's diatoms, things like that, to sort of start talking about rates of pollution in urban areas and, stuff like that. Obviously, we can talk about the taxonomy of the features and start talking about the security of various finds, and whether that's, if we're dealing with sort of deeply stratified Roman finds and things like that, we can talk about whether we think things are residual or not residual based on sort of the nature of the sediments they're contained in, whether there's been a lot of movement, how abrasive are the fragments, things like that. We can join in with the conversations with find specialists to, whether we think things are particularly mixed over a long period of time, a short period of time. And obviously we tie into the dating, using the absolute dating, radiocarbon dating, OSL dating, things like that for dating features and deposits. And, we can use the archaeological science techniques to sort of talk about activity areas and things like that. So we not just at the beginning talking about the wonders of landscape change, but also we do bring things to the table for archaeological discourse as well. A lot of the time in urban geoarch is spent on lab work. You'll go out and you'll do some coring or take some monolith samples, and then you'll do a quick description on site, and then you come back to the lab and you'll clean up the sediment, you'll take a photo, and you'll do a very, very detailed description of what bands are, what the compaction is, the color, the texture, whether there's any ripples, inclusions, bedding, what percentage of the fines are, what stone, rock type the gravel is, things like that. And then you'll do a provisional interpretation of how you think the deposit was laying down. So was it deposited by a fast flowing seasonal cold climate river? Was it sort of a still pooled flood deposit? Is a sort of a salt marsh, mud flat kind of situation? Is it a wetland? Aldercar? There's plenty of potential for that. And then I would usually go through and subsample for paleo environmental things. So yeah, classically, if sweeter things is pollen, ostracods, diatoms, and then in something for C14, things like that. Obviously, OSL needs to be kept in the dark, and so you can't really do it in the lab unless your core or monolith has been kept in total darkness and you're doing it under red light conditions. So it's sometimes better to do a separate one for that and do your paleo-environmental stuff on the light cores. But you can see from on the top left, you've got a classical sedimentary sequence of a ditch in Oxford for the city ditch for the medieval civil war defences even. So you've got the top core sort of made ground, then you've got sort of Oxford clay and sort of pooling, then various patches of organic deposit which are sort of dumped in. So you'd sort of record that in detail, then sort of as you interpret it, you work your way up into sort of from the basic deposits up to sort of units and contexts, and then group them together and try and get a feeling for what you're doing and what it means, basically. So it's sort of a iterative process in a way, of going from the basic recording up to the sort of large landscape, even meanings. So yeah, various different types of dating we use in sort of urban geoarch. OSL is a very big one at the moment because it's becoming a lot cheaper and a lot more detailed. You can do single aliquot dating now, so you can date one tiny piece of quartz, and that will give fluoresce under light conditions and tell you when it was last exposed to light. So if you're recording, say, a ditch or something, you can take 3 samples of that and get a rate for you infilling your ditch. And obviously do Bayesian statistics and things like that to work out what the time is and get a tighter date. I mean, it used to be when I first started, the sort of ballpark date for a OSL sample was 60 years at best, sort of 600. Now, 600 years, and now it's sort of, so it's quite good for doing, is this sand early Holocene or is it later? But in terms of trying to find out if a sandbank was in use in the Roman period or the medieval period, it wasn't as useful because the bracket was too big. But now you can get it down to sort of 30, 60 years sometimes if you take enough samples. So that's becoming quite powerful. Obviously, the fact has to be kept in the dark and not exposed to light does make it complicated, and you normally have to get a specialist out to do it. Otherwise, you're spending sort of a few £100 on something that might tell you it was last exposed to light last year, and it can be a bit embarrassing. Obviously, there's radiocarbon dating, which is quite common, but you obviously need an organic remain to date. AMS, it's classically and widely used. Obviously, we have to sort of think about for a lot of things we do from boreholes and things like that, and sediments and soils, has the thing we're dating moved, either by sort of soil formation processes, or has it been, has a river redeposited it or something like that, or has it moved down from slope processes? But I mean, that's not unusual. Obviously, if we're dealing with sort of waterfronts and channel reclamation and things like that, and we've got timber structures, we can do tree ring dating to date those features, and things like that. And obviously, there's relative dating involving finds and artifacts and things like that we can use to sort of date our deposits and put it into sort of a broad chronological framework. So we sort of get dates for the landscape changes we want to talk about. So usually things we try and date is sort of the onset of alluvium and flooding. When did peat layers start to form? When do they stop forming? When did sort of, sandbanks and things become sealed? They're sort of the big questions we can answer with that kind of absolute dating, basically. They're the kind of things we tend to look towards. And then obviously a big part of GeoArc is environmental reconstruction. So we sort of, as a rule, tend to want to sort of try and tell environmental stories about how things have changed since the last ice age. Obviously, there's various warming periods and cooling periods during that, the medieval warm period, the little ice age, things like that. We want to try and make those narratives and tie them into human occupation. It's the sort of big one as a GeoArc. So obviously we tend to use pollen because it survives in a lot of places quite well, and it gives you quite a good detail for sort of a broader landscape approach around the site. Use diatoms and ostracods for salinity and pollution measurement, things like that, because they tend to be quite fussy about where they live. Same with flora, and obviously we tie into archaeobotany for sort of evaluating what, say, peat deposits are, what kind of environment peat deposits like. Is it alder, is it reed beds, is it things like that? And archaeobotany, you know, what kind of marsh deposits are we on prior to areas being intensified and settled? And obviously it ties into, you know, your larger urban archaeological questions about economy and where people are getting their firewood from and their, you know, food from and all the other stuff. But the big sort of thing about GeoArc is we're trying to synthesize all that together from the different types, work out how it all ties together. Are they contradictory? Are they not? Do they all agree? And then put it in a chronological framework based on the sediment types we've got from the site. So we can sort of have a quite detailed sort of landscape story about what was going on in the area from the end of the last ice age up to it sort of being developed, urbanized, and to the modern day, and it's being redeveloped, or there's work going on it. Yes, it's my second case study, which is on Bloomberg Square, which is in the centre of London, right next to the Bank of England, basically sort of heart of Roman and medieval London. It's on the edge of a buried river called the River Walbrook. So we had one side of the site up where that big building is on the right-hand side, which is on the bank of the Walbrook, and then you've got the middle of it going through about where those people are standing at the bottom centre of it, which is sort of the edge of the Roman, the base of the Roman River. So at the sort of base of it, we had sort of 10 metres of Roman and medieval stratigraphy, dating from sort of, I think, AD 60, right the way up to sort of 1940s bomb rubble deposits from when London was firebombed in the Blitz. One of the things about that is I had a GeoArc on site throughout the entire investigation who would dig, manage areas of sort of, we had a lot of Roman houses and cityscapes and streetscapes. So we had a lot of alleyways and small buildings. So you do a lot. I did a lot of sampling of the floor deposits, things like that, sampling that, recording, generally running an area. And then when we had an area in the river valley, I'd pop off, do the recording, dig that, and then go back to what I was doing. So I'd sort of, they always had someone on site. So if someone would come along and go, Jason, what's this? Is it a flood deposit? I could look at it and say, yeah, it's, you know, very fine silt with, you know, bits of detrital wood in it. It's probably a flood deposit, and it's sandwiched between two floor deposits. So chances are it's the Walbrook flooding, and then you've got, you know, redevelopment. We also had sort of things like the evidence for the Hadrianic fire. So you had sort of burnt deposits which you could use for thermoluminescence dating to tighten that up. It was the site of the Temple of Mithras. We had very good waterlogged deposits. So there were things like shoes and Roman writing tablets with writing on it and things like that. So the preservation, you had sort of areas of higher, drier ground which had mediocre preservation, and then you had areas of heavily waterlogged remains which, you know, had very good organic preservation. So there was a need to sort of deal with both, as it were. So yeah, you can see it's in the middle of the city of London. We've got lots of leather things, leather boots, lots of waterlogged wood and revetment, things like that. Going out into the Walbrook, obviously with the caveat that the furthest out was the newest and it was older, so you had that sort of lateral strat thing as well as a vertical strat change. Yeah, we had lots of exciting Roman finds in that museum there, but sort of the interesting thing was sort of tying it into how we dug as sort of urban archaeologists and what we could sort of bring to that. So there's a lot of talking to diggers about what they found, trying not to get them to write the word natural in their context sheets and just leaving it, having to think about things in a slightly different way. That's the big one. It's quite useful for me as well, sort of in terms of I was also managing an area of digging, and then I was also managing a sampling strategy, various different small interventions into the river for lift shafts and things like that, and recording quaternary gravels and river for deposits and things like that, and sort of tying it all together. We also did a big auguring survey around the edge of where the sheet piling was going to go, so we could mitigate that before we put the sheet piling in, because that could be quite destructive. So we did 76 5-metre deep power auger holes, and then tried to tie it together in a deposit model to show what the potential boundaries were and how deep the deposits were, which failed miserably, because basically the little windows we had into the site and then was one thing, and then obviously when we dug an highly complicated Roman street pattern, it didn't really tally together very well. But obviously we could only sort of make the estimate on what we had. It was quite useful in sort of getting to see from the beginning of the process to the post-ex process and sort of follow it the whole way through, basically. So this is the sort of deposit model in early 2011. So while site work was ongoing, you can see that there's not that many points in the site boundary for Bloomberg. And there's sort of a lack of general ones in the landscape. Obviously, once the work has been done, you've got much better resolution of what the river channel's doing when it meets the Thames and what the deep channel's doing. I think that sort of blob up off to the left of the site is a well, but I could be wrong. I seem to remember that being a well, which is why it's wonky. Yeah, we got a much better idea of the channel morphology after having ground proofed it on site, basically, is the take home from that. So on site, the sort of question is, how do you recognise deposits of geoarchaeological potential? There's sort of different flavours you can get. There's sort of colluvial and hill wash deposits, which tend to be, I mean, they can be from sort of 10 centimetres thick up to a couple of metres of thick, depending on where you are. You tend to be at the bottom of a hill for that to happen. It doesn't really happen on the top of a hill, due to it being a slope process thing. The indicator for that tends to be very poorly mixed, poorly orientated, different class sizes, things of that nature. Sometimes there are buried land surface underneath it. Obviously, this can obscure any archaeology that's underneath it, like prehistoric things. Beaker settlements have a tendency to hide in valley bottoms and things like that. So that's something to be aware of. Alluvial deposits, so flood deposits, thin lenses of silt and sand, organic layers, things of that nature. Also, the potential to bury quite deeply in some cases prehistoric finds. There's a lot of sites in South London that are under 3 or 4 metres of alluvium, and then you've got various burnt mounds and prehistoric roundhouses, hard marks, that kind of stuff, once you take them off and scrape them off. Fluvial deposits, which, you know, gravelly, sandy, fast flowing river environments. You know, paleo channels tend to be filled with things like that, and then as the channel velocity slows down, it tends to go to a sort of a sandy silt and then a silty clay, and then usually someone's chucked some rubbish on top to seal it off finally. So, you know, a big cut with grading deposits is usually a good clue to the paleo channel. Obviously, you've got classic wetland deposits, which, you know, peats, organic clays and silts, which are formed from sort of sea level change, and the fact that it's too waterlogged for the plant and animal remains to decay. So you can see in the photo at the top, they've got sort of river gravels right at the bottom, and then various types of weathered alluvium sealing it. And yeah, the bottom one's got a bit of tufa and some organic-y clays and sands before yeah, the modern sort of soil's gone on top, and there's been some landscaping when it was used as a golf course. So as a geoarch, what do I classically want when I'm out field recording? Is the big question. I usually want as much detail as I can humanly get. So compaction, color. So I want, you know, fine, mid, dark, yellowy brown. I don't want strong brown, chocolate brown, any of the sort of slightly outre color system some people kind of use. I want the particle size and the texture. So I want to know if it's a sandy silt, a silty sand, is it a gravelly sand? I want to know what particle size the sand is, if there's any, is it fine, medium, coarse. I want to know how big the gravel bits are, what percentages it is, what percentage the inclusions are, what size they are. Are they rounded? Are they not rounded? Are they angular? Has there been any bioturbation, any rooting, any staining, any kind of evidence of post-depositional alteration? Evidence of any weathering, so iron staining, manganese, little sort of bits of dark staining. Yeah, I want to know if it's a sandy deposit or something like that. I want to know if there's any bedding or grading or sorting. So you can tell a lot about channel velocity by how sands and gravels are sorted and bedded. You know, is it declining? Is it getting faster? Are we on a sort of a curve of a river? That kind of stuff. And finally, as an interpretation, I want a broad idea of how it was deposited. Was it laid down in a flood? Was it, you know, wetland marsh deposition? Was it, you know, a river channel bed or something like that? Even if it's not perfect, if I'm, you know, if I'm dealing with archaeological interpretations, what I don't want is someone just writing natural and then leaving it, because that makes sort of coming back to it and sort of tying in an interpretation quite difficult. I once worked on a site in Northamptonshire where the diggers, we were on a site which had a chalk headland and a mudstone sort of floodplain base, and the diggers just kept writing natural on their contact sheets and wouldn't tell me if it was chalk or if it was mudstone, and sort of to trying to sort of map that and what the geology was doing and whether the geology map was accurate or inaccurate was quite complicated, because obviously geology map is landscape based and, you know, isn't always accurate to sort of the tens of meter scale. You know, because I'm trying to work out what's going on with that, and if it's accurate and good, the better the description, the happier I'll be. So a couple of years ago, I did a sort of a proof of concept of deposit model on Ireland. I did a little deposit model of medieval city of Kilkenny. So I took existing archaeological data from the Kilkenny Archaeology Project and various things online, and public accessible borehole data, GSI data, and LiDAR data. I put it all in a GIS database and constructed cross-section of floodplain and tried to reconstruct the Holocene surface and the sort of pre-medieval surface before a lot of the deposits on the floodplain were reclaimed in the medieval period. Try and correlate them. If there was dating of evidence available for the age, I put that in there to try and get an idea when things were backfilled and deposited. So we've got a very rudimentary deposition transect across the Nore Valley here. So you've got the sort of valley side deposits of the glacial sands and tills, and then you've got the sort of infilling in the made grounds, which sort of dates from 14th century up until the 20th century, some of it. And you've got various sort of wetland, channel islands and lower lying areas with flood deposits and organic deposits on top of it. So that higher area has got potential for sort of settlement in the way that sort of this deeper area of the modern channel doesn't have. I do have plans to get more data into this because some of the data is quite sparse, and I'd always like more. But it sort of shows you can start talking about sort of urban areas, how they're using their sort of marginal wetlands, things like that, how they're reclaiming land, that kind of stuff. So you can start talking about sort of broader landscape changes in the post-glacial period of how the river's changing, how the sort of braided river system's getting colonised and turned into a sort of a mono channel. So you can start talking about both the sort of wider landscape geoarchaeological questions and the sort of how that ties into medieval settlement and occupation and sort of into the post-medieval period. There we go. Yeah, a lot of what I have worked on over the last few years has been on flood alleviation schemes. Obviously, in the UK, we've had quite a lot of wet weather due to climate change and increasing storms. So there's been a sort of a aim to do more flood alleviation to try and remove the risk of flooding in urban areas, insurance claims, things like that. Obviously, there's a long history of human exploitation of floodplains and waterways and things like that. Obviously, we've now got the flood scheme guidance in from the NMI in Ireland, so it does reference Geoarch, so there's a potential for more work like that coming down the pipeline. Chosen to talk about Oxford a bit because obviously it is quite an urban area with quite a bad flooding problem, and basically it was used firstly as a sort of a tool to decide which areas were going to be investigated and mitigated and trial trenched. As you can see on the sort of top right hand diagram here. You can see the sort of deeper channels in the sort of neon colour, and then the sort of higher land in that sort of mustard colour. And then on the left-hand side, you can see the sort of general topography of Oxford, and that you've got sort of several limestone hills around the edges of the floodplain, and then you've got the Thames and the Cherwell coming through at the top. So yeah, one of the boons of the Oxford FAS was it was used to sort of deal with the Environment Agency, to show that we were taking the archaeology seriously and the geoarchaeology seriously, and it was used as sort of a planning tool for how the flood management scheme was going to work, and all that data fed in. So we could target which areas had thicker flood deposits and thus had been subject to more flooding historically, which fed into that. Also useful for stakeholders and local government authorities. Also, they used it to sort of do more deposit modelling in Oxford, and tied it into sort of areas of reclamation in the Roman period down in the south, down by Abingdon Road. There was a lot of infield bridges and things like that around there. Yeah, it's also quite good for, it was an unpopular scheme with the locals, basically, because although they didn't like the flooding, they also didn't like cutting trees down and putting a big channel through the open green space on the edge of Oxford. So a lot of that was sort of, we could do a lot of community engagement, things like that, and show we were doing due diligence and give them a feel for what Oxford was like in the past prior to the university kicking in, basically. Geoarchaeology has a part to play in future planning of cities, how cities are going to work, how cities are going to deal with climate change. It can be used as a flood prediction tool. It's been used in parts of London, sort of do planning on how certain transport elements are going to deal with flooding when the Thames barrier ceases to work and things like that. It's a good way for us to show policymakers and sort of higher government what the impacts of climate change are, to sort of try and get archaeology a seat at the table a bit more, and how these discussions are going to pan out. If we can show that, you know, certain bits of their constituency are going to be underwater in 30, 50, 100 years. We've got places like Jakarta in the top picture where there's sinking and there's going to be a lot of flood management problems and things like that. So I think GeoArch has a part to play in that, in sort of terms of what those islands have been doing sort of since the last ice age, and water, things like that. Obviously, you've got things like Tewkesbury when it had bad flooding about 10 years ago. There's a lot of archaeological work related to that, and a lot of stuff related to sort of flood management again. Conversations about food security as well, ties into a lot of things about that. Soil fertility, crop farming, things like that. I used to work at an agricultural crop science company. We had a lot of discussions about sort of crop farming in the past versus farming in the future versus intensification. And obviously it feeds into discussions about the Anthropocene and sort of the wider sort of talks about human environment interaction in sort of the post-industrial capitalist society in which we're in. So I think it does have things to say, stuff like that. I mean, there's the hunger stones they found in the Rhine a few years back for sort of, which exposed when there's drought, and was sort of a medieval warning that you might need more water, although obviously the hydrology of the Rhine has changed in the intervening couple of 100 years. So that's probably not as much of an issue, but it's still something to think about, and it's a useful pedagogic tool for talking to people who aren't into archaeology or geoarchaeology or past environments, to think about, you know, the baseline they've known isn't permanent and things will change. Also, geoarchaeology has been used in quite a lot of urban regeneration areas. Definitely in sort of East London, Docklands, things like that. Used on Bloomberg here, we can see this lovely modern art fountain of an infield stream. A lot of places like Earl's Court redevelopment in West London have sort of traded on their former thing as a sort of a bucolic countryside river, even if it was infield in the 19th century and chock full of rubbish when they put the railways in. So there's sort of lots of discussions about placemaking, development, how these sites fit in, you know, there's talk of rewilding and reopening rivers and stuff like that in urban areas, daylighting, all things that geoarchaeology has a big part to play. You know, I mean, even if it's just as a sort of a voice of reason when people are talking about daylighting a river that's now several meters below ground level, you know, need to sort of, you know, rein in expectation, things like that. But it does tie into sort of the future as well as the past is my sort of main point from that. So in summary, geoarchaeological and urban environments can provide a framework for other data sets to sit and be synthesized, mostly, you know, especially paleoenvironmental remains, archaeobotany, but also sort of fieldwork things, phasing it can assist with, that's sort of detailed sort of high grain settlement structure. You know, the microstat is very good on telling people, you know, doing really fine grained analysis about what's going on in areas of housing and how land's used to sort of complement sort of the urban stratigraphy and the taphonomy there to sort of have a bit more conversation about how the land's used, how the deposits have come into being, things like that. And I think it's a good way of value adding. Basically, it's an application of a limited resource to allow you to go a bit further with what you've got, you know, be it in terms of sort of pre-site evaluation and desk-based assessment, whether it's going out on site with a ground works crew and doing some detailed recording so you can construct a deposit model that allows you to descope half of the site because it's in a soggy, wet area that no one would have settled on. You know, policy discussions about the future and how sort of archaeology feeds into those kind of discussions. Yeah, I think that's it basically. So put up some resources about sort of archaeology. I've got the Historic England guidance for geoarchaeology, the deposit modelling guidance, and a Dutch book on the Big Book of Soil Profiles for archaeologists, which is quite good in terms of the pictures are very good in terms of mapping and section drawing and how to auger. And I've put a little story map up about the River Tyburn that Mola did a few years back, which sort of gives a nice sort of taster of going from the prehistoric landforms into the sort of medieval occupation of London and Westminster, things like that. So, yeah. Yeah, thank you very much for listening.
That's super, Jay. I would love to open the floor there to questions. If anyone has one they'd like to ask or type into the chat there. Just as something you kind of mentioned as a passaway comment, Jason, and maybe just expand on it a little bit more, is your comment about archaeologists using the term natural without any further explanation and how potentially that's not as helpful as, you know, we've decided that, you know, it's not anything archaeological significant, but that doesn't mean it doesn't contribute towards our understanding of the site. Is there anything else you'd like to say on that in particular?
I mean, just because it's sterile doesn't mean to say it's not archaeologically interesting would be my sort of general take on that. I mean, it's a pet peeve of mine, and I do have driven many of my fieldwork colleagues slightly mad by going, can you not say that? But yeah, I think it's sort of a question. It's getting people to think about landscape and what it means is the biggie. So basically that shows me that, you know, sometimes I know I get the desire to sort of go, yeah, that's it, we're done, we're in the natural, we can leave it. But I mean, also a lot of the stuff I do is on floodplain, and you know, you dig out a couple of meter flood deposit and then you're back in occupation again. So that's always slightly worries me in that I've done loads of sites over the years where there's more stuff underneath that people haven't always twigged, and then you go and auger it at the end and find more. So yeah, just a little bit more detail, and obviously it makes my life easier when you come to do the post-text and you're trying to work out what is the natural, even if you just sort of do it, even if I just get a description of what the natural is, that's at least something I can look at the geology map or the memoirs and sort of at least piece it together. As if I just get a one-word context sheet with the word natural on it, that makes life difficult. So yeah, it's about how you think about the landscape, really, I suppose.
That's fantastic. And we have a few questions just coming in now. I'll just read them out. Can you tell a bit more about the OSL process and how the sampling takes place on site? I'm curious about the contamination and how one can take a sample without exposing it to light. Is this something that can, sorry, that's my fault, I've got something in the way, can date specific features or more useful for dating strat layers on a site? Also, you mentioned the cost of the process going down. Can you give an estimate of the associated costs? That's from Emma Green.
So basically, there's a couple of ways you can do it on site. Basically, I tend to get a big sort of drain pipe about yay long, hammer it into the, I put a cap on the end of it, I hammer it into the side of the section. I then take it out very carefully. I put a black bin line around it and then tape it up. I then mark on which side is the external side and then send it off to the lab. And they'll know which side is the external side. So they tend to cut a bit off each end, which may have been contaminated, and then the inside a bit is safe. I have in the past done it with a big black tarpaulin over my head, but to be honest, taking a sample with a big black tarpaulin over my head in the dark is not ideal, just because it's painful. But I mean, if you're really worried about the contamination, contamination, that is one way of doing it. Price-wise, I think it's about £450 UK at the moment, give or take, depending on which lab you use. And it is coming down, because I think I remember it being sort of 800-ish when I started. But you can sort of, in terms of, you can pretty much say anything that's sand content. So you can do features, you can do layers. You only need like a single, you can do it on single grain now, but that's a bit more expensive because you need a longer count because there's less sand to go off of to fluoresce. But you can do it on sort of, even sort of sandy silts nowadays, things like that. You can do it on features, you can do it on layers, pretty much anything you want most of the time nowadays, just as long as you can get the core in and take some samples from the top and the bottom so it can be, they can work out the sort of background a bit more. But I mean, sometimes they haven't done that, so there's options there, I think. Yeah.
Fantastic. I have another question from Paul. What is your experience on how best to integrate geoarchaeology GI needs with those of ground modelling and geotechnical design to improve project efficiency and collaboration between allied disciplines?
I mean, it's having a chat early is the big one, I think. I've plenty of sites I've joined in later on and I've missed the sort of first phase of the GI or the planning of the GI, things like that. So a lot of the but a lot of the things you're doing for sort of ground modelling and geotechnical design, you're putting the boreholes in a lot of the time in places I wouldn't necessarily put a georock borehole per se. Which is fine, but if you're going to then come back on after a phase 2 or 3 do more geotech work, sometimes it's easier to piggyback and do a couple of boreholes in a sort of slightly soggier area to get a better feel for that, and then you can look at descoping or try and work out what needs to be done. But early communication and lots of communication would be my main one for that one. Getting them involved early is the big one for me, I think, even before the other archaeologists sometimes.
Thank you for that one. And then Sarah asks, could you expand on how to specify correctly for good sampling? If there are engineering site investigations that could also be used for archaeological analysis, what are the correct technical terms to get the right machinery?
I mean, most of sort of the engineering site investigations you can at least have a watching brief on, or get grab samples from, things like that. So usually sort of trial pitting, dynamic plate testing tends to be too shallow for most geoarchaeological things. Sort of quite a lot of rotary where they flush the top of the quaternary out with water isn't particularly useful for our needs, but most other sort of dynamic sampling, window sampling, things like that's great. Cable percussion rigs, window samplers are all good. If there's any hand augering on site, that's quite good to watch. The sort of main rigs, cable percussion rig, window samplers, and rotary rigs. Specifying correctly is sometimes a tricky one because even I've had trouble with that in the past where I've told the project manager for the drilling rig what I want on the day and they've turned up with something completely different. But writing a good tight spec is normally the solution for that, I think. I normally sort of specify sub-sampling, things like that. Any organic deposits of interest are normally what I tend to go for as a bracket things out. It's the sort of biggie.
Matt has asked, when you dig at a site, what are the parameters for depth that you go to? Is it based on the structure to be built, the land, or based on fine sediment, etc.?
It does vary. Sometimes it depends. It does depend on the impact depth a little bit. So if they're doing deep piling, then the piling will damage deep deposits and we'll have to mitigate with boreholes or something like that as a rule. If it's double basement, that'll take out, 6 meters of stratum, take out most of the Holocene, if not all of the Holocene deposits in somewhere like London or whatever. So it does tend to go off that. Obviously, if you're doing GI works and drilling to 50 meters, you're still impacting those sediments anyway. So you can usually argue for a watching brief or something of that nature on there. So it does tend to be dictated by what's happening and what the building methodology is. But it does tend to be that the building methodology on soft, squidgy quaternary sediments does tend to be pile based. And thus you've usually got a window for something, even if it's just reviewing the logs afterwards. So it does tend to be based on what's being built and the impact depths of that. Is the biggie. I mean, sometimes it depends on what the local authority wants. Sometimes they want deeper stuff. But I mean, that's when you sort of start having a conversation about, do we need to do it? Do you want to do it? What are you hoping to get out of this? That kind of thing.
And Cian has a question related to lithics. So with boreholes and test pitting, are there stone types that appear near surface recorded by type at all? Or is this level of detail possible given time frames, working conditions? There would be a valuable contribution to discussions on resource availability.
I try to record the stone types, but I'm not I have some geological training, but I'm not an actual geologist, so I do my best normally. Good geoarch description should have stone type, rock type, things like that on it, ideally. But sometimes it can, I've read logs where it's just sedimentary, metamorphic, igneous before, we try to, as a rule.
And just a kind of a comment, it would be good to consider about the use of some boreholes compared to test trenches cost-wise. Also, a couple of boreholes can often be easier to undertake in urban environments compared to test trenching to get information.
Yeah.
Also, folks, please do feel free to ask these questions yourself. You don't need to listen to me reading them all. You can definitely raise your hand or unmute yourself too.
The big problem with those deep trenches is the spoil storage. That's the big problem.
Absolutely. Let me just see if I have any other questions here. Maeve has asked, have you examples of projects you've worked on where the geoarchaeological evidence has informed the pilling strategy agreed for the construction project? Archaeological excavation and urban construction projects can be to a limited and agreed depth and extensive archaeological deposits very below information level of the new build. Can be belowed.
Generally, as a rule, archaeological deposits are... No, actually, I did a job in Dagenham a few years back where we had a cluster of bit of work wood, bit of fire crack flint, and some microdebitage come out at about 9 meters below ground. Because they were piling it, we just got them to move the piles a bit away from where that bit was. So we didn't truncate the prehistoric stuff. But as a rule, geoarch stuff tends to be layer based, whereas if it's archaeological, like a bathhouse, that's something you can definitely move the piles away from. But sort of geoarch wise, you tend to sort of, as a rule, mitigate with a purposive borehole and then do analysis on it, more than moving the piles for stuff, I think. I've sometimes had to move for engineering reasons because the deposit's too soft, but that's a slightly different use case.
Fantastic. And then Paul just commented, coming back to Sarah's question earlier, just for engineering schemes, I'd suggest collaborating with the engineering geology team who will be familiar with the GI specifications and bills of quantity to recover most of the sort of samples needed for geoarch. There's useful guidance in Heritage England docs that Jason has referenced. And just to say as well, Jason very kindly offered to take questions by email over the next week. So if there's something kind of more detailed or something occurs to you in the next few days, please do feel free to pop it in an email to me, and we'll get it across to Jason as well. And then Matt has just said how much HSE is involved and is third party bought in to cover this.
Is HSE Health and Safety Executive, or is it something different?
I assume they mean Health Service Executive here, but I could be entirely
Cool.
wrong.
Normally we sort of go through whatever the construction company's health and safety is, and usually the in-house, whatever company I'm working for is health and safety. I have worked with companies that've got their staff trained in how to construct shoring and things like that, but I think that's a bit excessive. But yeah, normally it tends to go through sort of a definite temporary works program for a lot of some of the deeper trenching.
And Daisy just has a comment on the Kilkenny project. She was just wondering how this was received and what it was thought of your results, as I think she thinks that there is still quite a limited use of GeoArc in Ireland compared with the UK.
Yeah, I presented it at the IAI year before this year, and I presented it at the Developing International GeoArc Conference in Germany last year, and it seemed to go down very well. Yeah, I think it was more of a food for thought thing than any sort of grand, excitement and wonderment. But it shows what can be done, basically. So, yeah.
And just to say, no, yeah, this has been recorded, so we will have it available on the II website in a couple of weeks once it's had a chance to go as far as our editor and be approved by Jason. But yeah, is there any kind of final comments or questions that you'd like to put to Jason while we still have him in the room?
I have a question. If am I audible?
Yeah, yep. Simon, I can hear you. Yeah.
Okay. Thank you. Yes, thank you, Jason, for it was very interesting to hear geoarchaeology in a different country to my own. I'm quite used to, well, I've learned about Sweden's geoarchaeology while I've studied, but it was quite interesting to hear about the UK's and a bit of Ireland's. I was just interested to know, because I'm not quite familiar with the OSL dating technique. You mentioned that you can date quartz using it when they were last exposed to daylight. Can you also date other lithic types, or is it just certain ones?
I think you can date feldspar, but I could be wrong. Yeah, I only understand a bit of it. I find it quite complicated, some of the sort of ins and outs. But anything, I think it's due to how the crystalline structure fluoresces under sunlight, and then then it's exposed to quite a lot of light, then remeasured, I think. So yeah, I think it's more about how the quartz crystals luminesce. So I think it can be done on feldspar, and I think there's looking at other things, but it's mostly been quartz that's been worked on, I think, as far as I'm aware.
All right, interesting. I was also wondering a bit about the flood prediction. I thought that was very interesting. Is there any recent publications regarding that? Like, I would love to read more about it.
I will send you a list of things because I've got a little bibliography somewhere. Yeah, not a problem. So there's a few things recently that have come out.
Oh, thank you. Yeah, that's all I was wondering otherwise. But yeah, thank you very much for very
Simon.
interesting.
Sorry, just to pop there for a second. We had some OSL dating done recently, and they could date quartz and potassium feldspar. Just let you know.
Thanks, Asha.
Oh, right. Okay, thank you.
I think that the advice is to engage with your lab before you take the sample to make sure that what you're wanting to do is technically feasible in those materials and the specific environment that you're looking at.
That makes sense. My thanks. Thanks again. Sorry, that was my Dublin coming through. That was a thanks with no H. My thanks again to Jason for a really, really interesting talk. I think we definitely are lacking at times on GeoArch in Ireland. So it's really great to see all the work that can be done. And look, you can see the thanks in the comments there as well, Jason. We'll wrap it up, folks. Thanks for your time and attention today. We'll have hopefully a recording of this up on the II website in the coming weeks for anyone who'd like to revisit it, for any of your colleagues who might have missed it. So I'm going to leave it there, folks, and we'll talk to you soon. Thank you, Jason, for your time today.
Thank you very much, everyone.